Hey everybody, I wanted to spend a little bit of time talking about states of matter, and then we're going to talk about state changes. So let's just briefly go over what the states of matter are. You probably know that there are solids, liquids, and gases. Okay, so a solid is something where the particles, if we look really closely at a piece of matter, it'll be made up of particles. So I will draw a piece of matter here, and I will look at this, and inside that state of matter, or when we zoom in really close, there'll be particles that make it up. And so what makes a solid is that these particles are very, very close together. Okay, and what causes them to be close together is because they're strongly attracted to each other. Okay, it's almost like these two things, these two particles are attracted to each other because they have a magnetic attraction. Okay, a strong magnetic attraction, think of it like that. And then the same thing is with this particle and this particle, strong magnetic attraction. And this particle, strong magnetic, it's being pulled together. So that's why they're close together. And because they are very close together, you end up having very little movement. These particles inside a solid aren't moving very much because there's no space for them to move. It's like all of these guys are sitting in a mosh pit at a concert, and they can't really do much. Okay, and so because of that, you end up having a definite shape and a definite volume. If I take a solid and I put it on a table, it maintains its shape. It's not going to like flow over like if I were to put like a slime or something on the table. Okay, a solid is something that maintains its shape because these particles are so close together. Okay, not only does it maintain its shape, it maintains its volume too. It has a definite volume. Now a liquid, when we look at the particles, they will be a little further apart. Okay, so these particles now in a liquid, like liquid water, have some attraction. They're like kind of attracted to each other, but they're still able to move a lot more. And so because they have less attraction and that they are further apart, this gives them an indefinite shape. So if I take slime and put it on the table, it flows and kind of overflows flows across the table. Okay, that's what a liquid does. It doesn't hold its shape because these guys are moving a little more, but it does maintain its volume. So now a gas, if we look at the particles that make them up, they're going to be super far apart, and they're going to be so far apart that they don't even interact with each other. There's zero attraction between particles in a gas. And because they're so far apart and that there's no attraction, these guys can move all over the place. They can go anywhere that they want, and they don't have to worry about anything. So they're not even at the concert, right? So if solids are in the mosh pit, gases are listening to the concert, but they're not doing it anywhere near anybody, and they're just moving and marching to the beat of their own drummer. Okay? And so because of that, a gas has no shape. It takes the shape of its container because the molecules are moving all around. But the molecules also can spread out and have a change in volume. You can also push on them, and you can push the molecules or the particles closer together. So that means that a gas doesn't have a defined volume either. Okay? So let me talk a little bit about state changes. Okay? So there's two types of state changes. One where the particles are going to get closer together. Okay, and those are freezing, condensation, and deposition. And then there's a type of state change where the particles are going to move further apart, and that's boiling, melting, and what we call sublimation. Okay, you've probably heard of the first two in each of these, but the last one may be something a little bit different. Okay, but it's all kind of the same idea. Okay, so let me pull up a simulator and show you what we mean about the particles getting closer or moving further apart. So here's a simulator of neon gas, and we'll just use neon gas as our particle. Okay, and so notice here the particles are very, very close together. Okay, well, what state of matter has the particles very close together? Yes, that's a solid, correct. Okay, so what we're going to do is we're going to force the molecules to move further apart into a liquid. The difference between a solid and a liquid is the liquid has the molecules a little further apart, and we're going to do that by heating up stuff. So when we heat up this, the neon, notice what's happening to the molecules now, or the particles are now starting to fall. They're not maintaining their shape. They're kind of moving a little more, and they're doing their thing. Okay, some are even jumping off here and moving independently from each other, but most of them are staying down here. They're kind of attracted to each other, but notice they're not maintaining a shape. I have now turned all of this into a liquid. I've turned this into liquid neon. Okay, so now if I move the particles a little further apart using heat, I'm going to heat them up. Now look at what happens to particles. Okay, now look, the particles are moving completely independent from each other. They're not trying to stay close together. Sometimes they conglomerate and get close together, but if you just take a look at some of these guys, they're just moving around. They're doing their own thing. So now I've turned it into a gas. So those are state changes, okay? So what we did here is we've moved the particles further apart, okay? So we started with a solid and went to a liquid, and that's melting. That's what melting is when we move the particles a little bit further apart and allowed them to move a little bit more. And then we go from a liquid to a gas, which is called boiling or evaporating. We've moved the molecules even further apart and caused them to move even more independently. They're moving as they wish. Okay. Now, the state changes that require us to push them closer together or cause them to move less, well, if we go from a gas, here's a gas, I'm going to cool this down now. So I'm going to go from a gas to a liquid. Notice now the particles are starting to bunch up a little. They're starting to become a little bit attracted to each other. Okay, so when they do that, that's going from a gas to a liquid. That's condensation. You can see, let me see if I can get it going really good here. Okay, so notice now the particles are starting to bunch up. Okay, they're attracted to each other, but notice they're not like in a rigid shape. They're just kind of flowing all over the place. Now that's a liquid. I've condensed the gas into a liquid. So now I'm going to cool it down even more and cause those particles to not move even more. And when I do that, notice now these guys aren't moving at all. This shape is going to be this shape. And then when the new ones come in, they're just kind of shaking in one place. They're back in that mosh pit at the concert, right? Here's a loose one. This one will eventually come back in, and it's not going to move its spot. Okay, I've been looking right here, and that hole is going to stay there forever and ever. So it's got a definite shape, and its volume is going to stay the same. Okay, and so that's freezing. So there it is, states of matter and state changes, and I hope that helps you out. Have a great day, everybody.